Welcome to the Unit 6 homework tutorial for pages 8 and 9. Here we go. Okay, so the first one I did not actually highlight, but I wanted to go over this one more time. What 3 units can a particle represent? It's anything in our MAPFU. So when we're talking about particles, that's the P. It can either be molecules, atoms, or formula units. So particle is a general term. Okay, just remember MAPFU. So molecules, atoms, particles, or formula units. Formula units. And why not? We'll go ahead and make that our first +2 bonus right there. Okay, so next question. How many atoms of aluminum fluoride would have a mass of 25 grams? Always start with boxing and circling. Box your given. My given here is 25 grams. My unknown is how many atoms. And we already gave you the molar mass for this. How nice. So we'll always start with what we are given. Given 25 grams of AlF3. I'm going to just go down my unit so I know what to do next. 1 mole of aluminum trifluoride is going to have a molar mass, which we tell you up here, so nice, 83.976. That weighs the grams, so our grams would cancel out. However, I am not finished because I am not trying to solve for moles, trying to solve for atoms. So I have one more step. Okay, one more step. Just go down mole, and 1 mole of AlF3. I know that 1 mole of anything is equal to Avogadro's number. Okay, 1 mole of anything is always equal to 6.02 times 10 to the 23rd. So then I can multiply everything on the top. So sometimes I just draw like a little parenthesis. So I remember to put things in parentheses. Then I write my little multiply sign. Close my parenthesis. Then I write my little divide. Open a new parenthesis. Times everything on the bottom. Okay? So I'm going to multiply what's on top and divide it by 83.976. So plug that in your calculator. 25 times 1 times 6.02, EE key, 23, close my parenthesis, divide, start a new parenthesis. Then I'm going to plug in my molar mass there from the problem, which is 83.976. And then I'm multiplying that by 1. I know you don't have to multiply by 1, but I think it's good to get into the habit of working with these parentheses, right? Because won't always be 1 later, and that is going to equal 1.79 times 10 to the 23rd. Ten to the 23rd what? 10 to the 23rd atoms, because we got to include our units in our answer. Okay, next problem. How many formula units? Oh, formula units. Again, I want to be thinking about MAPFU. So we know our answer is going to have that Avogadro's number, right? MAPFU, formula units, there it is. That's what we're looking for. How many formula units are going to make a 25 gram mass? So this one is very similar to the other one. So we'll go quick. 25 grams of sodium chloride. Just go down my unit. Grams sodium chloride is equal to 1 mole. However, I am not solving for moles. I am solving for formula units. Sometimes you can even write out all your units first and then fill in the things that you need to fill in. Then I can show you that right now. So 1 mole of NaCl, just go down 1 mole, NaCl is going to be equal to, we're solving for formula units. That is the actual abbreviation, okay? So our formula units are, there's always 6.02 times 10 to the 23rd formula units in 1 mole of anything. So the last blank, the one normally we would make you solve for this, but we were nice today and just gave it to you. But if you had to solve for it, all you would have to do is just add these up. That 22.99 plus that 35.453. So that's where that number came from, that 58.443. Alright, and solve just like we did before. Multiply everything on the top, so 25 times 6.02, EE key, 23rd. Close your parentheses if you're doing it all in one step. And then you're going to divide that by 58.443. So there's my answer, 2.57, or you could round that up, you could say 2.58 times 10 to the 23rd. 2.58 times 10 to the 23rd formula units. 2.5. Don't forget to write your unit. I'll give you another bonus point. Plus 2 FU formula unit. Not a curse word. It stands for formula unit. Sorry about my terrible handwriting there. Next one. Alright. 25 gram sample of sodium nitride would be made of how many formula units? And again, we gave this to you, but it's a little 3-step process, exact same setup. So box your given, circle your unknown, we're looking for formula units, and then here we go. See, what I love about these is once you get it, you really get it. It's very repetitive. So it's really easy to just start going quick on these problems. Okay, so we got our 25 gram, I'm going to just go down, gram of sodium nitride. We already figured out the molar mass for you, but again, if we didn't give it to you, you could figure that out by saying 3 times the mass of sodium plus the mass of nitrogen. Okay, so that's where that number came from, this 65.011. Alright, and that is in 1 mole. We are not done yet though, because we're not solving for moles, we're solving for formula units, so we have to go one step over. So 1 mole of Na3N. Just go down. 1 mole of Na3N is equal to, we want our answer to be in formula units, there are FU, 6.02 times 10 to the 23rd, because that is how many MAPFUs, molecules, atoms, particles, formula units are in 1 mole of anything. And solve. See how everything will cancel out because I wrote out all my units, so everything except for what we are looking for will cancel out. The only thing we're going to be left with are the formula units. So I'm going to plug it into my calculator. I'm going to say 25 times 1 times 6.02 times 10 to the 23rd. Then I'm going to divide that by 65.011 times 1. There's my answer, 2.31, because 4 will not round up, 2.31 times 10 to the 23rd formula units. 2.31 times 10 to the 23rd formula units. Alright, now let's flip over to page 9. this is some nice review of naming. We don't want to be forgetting about how we are going to name things. So let's see, we'll do this first one. Lead 4 sulfate. 4-step formula, because lead is a metal, right? We know lead is a metal, so we have to use the ionic naming system. Plus it told me right there. So lead, first step is symbols. Lead is the symbol Pb. Sulfate, the formula, their symbol there. We're going to use our handy dandy chart, find sulfate, that is SO4 with a -2 charge. SO4 with a -2 charge. The Roman numeral tells us the oxidation on the lead, so the oxidation is 4. Don't make your life hard. Let the Roman numeral tell you what to do. Okay, crisscross. The 4 is going to come over here. The 2 is going to come over here. See, we just crisscrossed. Last step, we need to reduce. 2 and 4 can both be divided by 2. So whenever I reduce them, I'm going to end up 2 divided by 2 is 1. 4 divided by 2 is 2. So that is my formula. PbSO4 2. Next one, I'm going to do this one. Here's my formula. Silver, we've got some silver. Ag, just as a quick refresh, that is silver. Silver is in the exception block. So silver does not need a Roman numeral in its name because it always has a charge of +1. And it is paired up with P. P is phosphorus, so it's going to be silver phosphide. And this is ionic. This one right here, we need to decide if it's ionic or covalent. I just need to look at the first one to make that determination. This is nitrogen. Nitrogen is not a metal, so this must be covalent. So that means I need to use prefixes in the name. So this is prefix for 2, di-nitrogen. Prefix for 4 is tetra, tetroxide. Alright, so really easy breezy. And let's see, we'll do, how about what if you have neither of these? I can figure that out. This is the only example that's making you do it this way, because usually we're giving you one or the other. So if you have the formula, you can also figure out what the name is. First, look at this. Is it a metal or a non-metal? Silicon is a non-metal. It is technically a transition metal, but since it is on the right side of the stairs, we're going to consider it a non-metal, which means we're going to use it naming the covalent naming system. There are 3 of them, so I'm going to say tri-silicon 8. Okay, so think about what that prefix is. Okay, that is octa. Iodine. That's a weird combination there, but there it is. Alright, so that was a good little review. Okay, next ones, we're going to do some SI units. I just picked a few that are quite commonly missed. Time, for some reason, students get confused on this, but it is usually in our SI unit is seconds. Molar mass, that is grams per mole. Amount, this is always missed. The SI unit for amount in chemistry is the mole. And length, that is meter. Don't tell me inches. Okay, it's not inches. We're doing science here. Alright, and I know y'all can get these other ones on your own. So let's start doing some problems. How many grams are in 0.682 moles of lithium? So box your given, circle your unknown. Box, circle. Alright, always begin with what you are given. I am given moles. And I'm going to just go down, mole, L-I, just go down. And I'm trying to get to my grams. So, in 1 mole of lithium, all I need to do is look at my periodic table. I only have 1 mole. There's 1 mole weighs 6.941 grams. Have I gotten to what I circled? Yes. So I am all done. Those are my steps. I just need to multiply those two numbers. So 0.0682 times 6.941, and that is going to be equal to 0.47, and I'm going to go ahead and stop rounding there, grams. Okay, let's keep going. Number 5. How many molecules are in, so this is something different. Before I was solving for grams, now I'm solving for molecules. How many molecules are in 0.347 moles of sulfur trioxide? Always start with what you are given. Let the units do the work. Just go down your unit. In 1 mole of SO3, I'm looking for molecules, so you can write that up top. Remember, MAPFU, molecules, atoms, particles, formula units, there are 6.02 times 10 to the 23rd molecules in 1 mole. It's always 6.02 times 10 to the 23rd when you're talking about anything that is molecules, atoms, particles, or formula units, MAPFU. And what I circled matches this unit in this box, so I know I have no more steps. So it's time to solve. I'm going to solve by multiplying 0.347 times 6.02 E key 23. Enter. There's my answer. It is 2 point, I'm going to round that up, 2.1, because the 8 will round up that 0, times 10 to the 23rd. So that is equal to 2.1 times 10 to the 23rd. And my unit is molecules. Okay, here we go. And I circled number 7, but I actually think I'm going to do number 6 for you because it's a little more challenging. So I think it's going to help you out more if I do that one. I'm going to use a different color so we don't get them confused since I write kind of big. So I'm looking for moles, and I'm going to box this. This is my given information, 1.3 times 10 to the 23 formula units of aluminum cyanide. Okay, so I'm going to start with the 1.3 times 10 to the 23rd formula units of aluminum cyanide. Okay, so just go down, formula units. Remember, that is your signal. Formula units is in MAPFU. When we're thinking about MAPFU, we're thinking about 1 mole is always equal to Avogadro's number. That's 6.02 times 10 to the 23rd. Okay? And that is always equal to 1 mole. So, plug that in your calculator. We just need to divide these two numbers. 1.3 to the 23rd divided by 6.02 to the 23rd, and that will give me 0.22 moles, because I just rounded it a little bit. 0.22 moles aluminum cyanide. Okay, so that is, I'll go ahead and do number 7. We'll do number 7 and then we're going to be done. Okay, so I'm going to circle that, box this. Okay, start with what you are given, 3.73 times 10 to the 24th atoms, barium, just go down, atoms. Remember, that's part of MAPFU, that's the A, so 6.02 times 10 to the 23rd in 1 mole. Now we're not looking for mole though, we're looking for grams. And 1 mole of barium, I'm going to just go down, mole barium. 1 mole of barium is going to be in grams equal to the molar mass. So we're going to use our periodic table. And that is easy enough to find. There it is. We've only got one of them, so it's 137.328. So here we go. Multiply what's on top. So imagine putting like a parenthesis, hitting multiply. So 3.73 E 24 times 1 times 137.328 divided by 6.02 E 23. There we go. So we've got 850.9 grams barium. 850.9 grams. All right. And your last little bonus code. Here it is. Have a great day.